In this episode, I would like to address the comment of one of my viewers regarding possible optimization of draw fill rectangle function. As you can see in the comment, fill around rectangles should be twice faster than regular fill rectangle function. It seems to be weird, as drawing rectangles with rounded corners should be more complicated. However, indeed, I observed that execution time of many comments depends on which comment of RA8875 you will use. So let's check it. First of all, why it is important. Draw fill rectangles is one of the most frequently used functions. Whenever you want to clear screen area or draw a window implementing graphics user interface, you have to draw filled rectangles. So performance of this simple function can affect the responsiveness and smoothness of the whole graphics system. That's why it is important to optimize this function. So I was able to identify a couple of different methods of drawing filled rectangles. First one uses block transfer engine and solid fill function of this subsystem. The second and the third ones both using geometric pattern drawing engine, square input and square of circle corner input functions respectively. The last method uses memory clear function. This function can clear the whole screen area or can clear only a part of the screen as well. So the question is, which of the above methods is the fastest? So here are the functions. As you can see, all functions have the same argument, which is the size of a rectangle. Basically, the functions send simple commands to the RA8875, which are, as a result, responsible for drawing rectangles. The execution time of function is stored in times array. At the end, the execution times expressed as the number of cycles are displayed on the screen. To measure execution time of mentioned functions, I assembled a test hardware, as you can see on the film. So here is my test hardware, which consists of 7-inch display 800 by 480 pixels controlled by RA8875. The LCD controller is connected to Atmega 4809 using 8-bit parallel bus. Actually, the bus type is not important. You can use serial bus as well, because all I have to do is send a couple of bytes to RA, which are the actual commands. To measure execution time, I will use the wait signal generated by the RA8875. Wait signal is active when RA is busy executing command. So in my test circuit, I will connect the wait signal by the event system to the timer TCB0, which works in pulse measurement mode. So high to low transition of wait signal will clear the CNT register, and low to high transition will restore the current CNT register value in CCMP register. Thus, I can measure the execution time with very high accuracy, which equals to 2 CPU cycles. I will measure execution times independently for 16-bit and 8-bit color modes. And here are the results. First, let's take a look on oscillogram. We can clearly see that different functions are executed with different speed, and the fastest one seems to be draw rounded rectangles or memory clear function. Let's take a look on the results displayed on LCD screen. As suspected, both functions perform really well, especially in compared to BTE solid fill function. And in 8-bit color mode, it seems that execution time of some of the functions is a little bit faster. By the way, the displayed values are expressed in number of timer counts, and one timer count equals to 2 CPU clock. So you can easily express results in, for example, milliseconds using this simple equation. Let's take a look at the following chart. As you can see, the slowest is BTE solid fill function. The draw rectangle function is indeed about twice slower in compared to the square of circle corner function. However, the fastest function seems to be the memory clear function. However, the difference between the last two functions can be neglected, as execution time difference is really small. Very similar results can be observed in 8-bit color mode. Execution time of BTE solid fill function is exactly the same as it is in the 16-bit color mode. However, other functions seems to be executed a little bit faster. So the conclusion is that if you want to squeeze all the performance from the RA8875, you should use memory clear function or square of circle corner function, as mentioned by one of my viewers. So thanks for this hint. I hope you enjoyed this episode, and please don't forget to leave comments below if you have any questions or ideas. Cheers!